My name is Jeffrey Frankel, and I have shown students techniques to reduce the time answer questions in paper 1 of the IB chemistry exam at both levels, standard level and higher level. These questions are multiple choice. You have 90 seconds available for each question, and you have no calculator. These techniques that I am about to show you will help you dramatically reduce the time needed to answer those questions correctly in maybe 30 or 40 seconds, and in some cases even less, thus giving you extra time to do other questions within the paper.
As soon as you're asked a question about homologous series, in the back of your mind you've got to have the ideas about what a homologous series is. The individual members within a homologous series differ by CH2. You have to know that. There is a trend in physical properties through the series, physical properties. And by that I mean that the early members may well be gases like methane and ethane in the homologous series of alkanes. Some of the middle members, pentane, hexane, are liquids. And the later members, the higher members, when it's C20 or higher, are solids. So there's a trend in physical properties, and that applies to melting points, boiling points, and various other types of properties that can be discussed. In chemical properties, they have similar chemical properties. Best to remember the name similar, because they don't have the same chemical properties. They do not have the same chemical properties. They have similar chemical properties. And the final thing about homologous series is that they have a general formula. A general formula. It's the general formula that gives you the individual formulae for a particular member. They don't have the same empirical formula, they don't have the same molecular formula. It's a general formula. Okay, so having these in the back of your mind, you can quickly look through this and say, well, it's obviously not this is wrong. They do not differ by CH3. The members of the series have the same physical properties? No, they do not. They have a trend in physical properties. Members of the series have the same empirical formula? No, they do not. Members of the series have similar chemical properties. This is the answer. Homologous series. You have to know the meaning of that. And all the alkanes, say methane, ethane, propane, butane, are part of a homologous series. All the alcohols, methanol, ethanol, propanol, butanol, pentanol, they are members of the homologous series. And in this case, what you're looking for is something which is the same as chloropropane, but is either, instead of propane, is ethane, butane, pentane. And lo and behold, as you look through it and you see B, 1-chlorobutane, is clearly the member of the same homologous series. Bromo is not, because it's bromo. Dichloro is not, even though it's propane. Dichloro is not, because it's dichloro. It's got to be similar to this, but with only an extra CH2, and the butane one is the only one that fits with the extra CH2. Oh, this is another one where you should know what a molecular formula is, and you need to know what the essential definition is of it, so that you recognize the correct word. As you look through this, you see the first one. It's an integral or integer multiple of the empirical formula. Without thinking further, less than 10 seconds you can get that. You can quickly look through the others, and it shows how the atoms are bonded together. No, it doesn't. It's the smallest ratio between the atoms. No, it isn't. That's the empirical formula. It's the percentage composition? No, it isn't. So that confirms that. Within 15 seconds, you can confirm that that is the only one. And as I've suggested before, in these kind of definitions, there are certain words you must know those words within any definition, and you must know what you're looking for. Empirical formula, you're looking for ratio or simplest ratio of numbers, and you look through this, and there it is. Formula showing the simplest ratio of numbers of atoms of each element in a compound. That is what the empirical formula definitely is. And then you check through the others. Formula showing the number of atoms present in the compound? No, it isn't. Formula showing the number of elements present in the compound? No, it isn't. Formula showing the actual numbers of atoms for each element in a compound? No, it isn't. The empirical formula is the formula showing the simplest ratio of numbers of atoms of each element in a compound. Simplest ratio of numbers. This is one of those questions within organic chemistry where it's essential to see patterns. And it's important to realize that this cannot represent another compound because this is the structure of a compound. This is the structure of a compound. So those two are out. So it's a matter of either this or this. And it's also important to realize that with C3H8, there is no possibility of isomers. There is only one possible chemical that fits that, one possible structure that fits that, because it has this kind of molecular formula, molecular structure, displayed structure. There is no possibility of rearranging that, and you should have learned early on in your organic chemistry studies that there are no possible isomers of that. But there are possible isomers of C4H10. Therefore, this one is the only one that can represent more than one compound, and that is clearly the answer. Examiners like to see that if you can use a concept from one part of chemistry in another part of chemistry. And empirical formulas generally are discussed within organic chemistry, and the reason for that is that many organic chemicals have both a molecular formula and an empirical formula. In the case of inorganic chemistry, the empirical formula and the molecular formula are the same. It's just a fact of life, it's a fact of chemistry. And so what we've got here is a mixture of organic chemicals, C2H4 and C6H6, and some inorganic ones, B2H6 and Al2O3. And you're expected to immediately realize it shouldn't take you more than 5 seconds, 10 seconds at the most, that this is the only empirical formula. When you look at this, you've got to clearly determine the empirical formulae, and then you can determine which one has the largest mass. And immediately you can see that it's this one. So that is it. So this is a matter of working fast, knowing exactly what it means by empirical formula and writing them down, or if not, maybe you can do this one in your head. But certainly it's a matter of being able to see the empirical formulae within these molecular formula very quickly. As soon as you see this statement, decolorized bromine water in the dark, you know you're looking for a double bond. And you have to know the characteristics of a double bond, or at least what it looks like in terms of formula. You look at the first one, you immediately see there are no double bonds there. There's a carbon double bond O, but that's not the double bond we're looking for. We're looking for a C double bond C, or a CC double bond. We look at this. This is all saturated stuff, so it's not going to be affected by bromine water. And then we come to this one, the CH. That is the indicator of a double bond, CH-CH. And this is all saturated, so that's not there. So the answer is this one. You're looking for a carbon-carbon double bond, and a CH-CH is indicative of a double bond between the two carbons. This is an interesting one. Which one is not an isomer of hexane? Immediately you see hexane, you know hexane is a saturated alkane. And as you look through this list, you will see, without even thinking about them, you will see this structure, CH-CH. And I've mentioned it before. CH-CH indicates a double bond. It's a double bond between those two carbon atoms. And therefore this one, it cannot be an isomer of hexane without even looking at the others. That one cannot be an isomer of hexane. The CH-CH is typical of a double bond, a carbon-carbon double bond. Remember that. Okay, so you're asked for the structural formula of propan-2-ol. As soon as you see propan-2-ol, you must remember 3 carbon atoms. And the second thing you remember, if it's 2-ol, the OH is on the second or the middle carbon. And as soon as those two phrases come into your mind, that it's 3 carbon atoms, the OH is on the middle carbon, you go immediately to this one. You just see it without thinking about it. Without thinking about it, you go there. And then you can check. It's not that, because that's 1-ol. It's not this, because this is butanol. It's butan-2-ol. And it's not this, because it's a ketone. So by thinking about the propan, that it's 3 carbons, and the ol is on the middle carbon, you can immediately see that. Now, the important thing about when you read this question, you should immediately, in your mind, remember what an ester is. An ester must have within it C-double-O and another C after it. So C-O-O-C, ester. C-O-O-C, ester. C-O-O-C, ester. This one, not an ester. Okay, so let's go back to ethanoate. Let's look at that, the acid part. The acid part is ethanoate. Ethanoate means 2 carbon atoms. So as soon as you're looking for the acid part, you're looking at the C, the first C, C-O-O. Look at the first C, and it's C and C. Oh, that's ethan. That's good. Here, definitely no. Here, no. So, we go back to the first one. It must be the first one, because that's the only ethanoate. And lo and behold, propyl is 3 carbons. 1, 2, 3. Now, the thing about esters is that we write them with the acid first and then the alcohol. That we name them with the alcohol, propyl or propanol, and then the acid, ethanoic. Ethanoate from ethanoic. So, just remember the ester is written back to front relative to the name. And sometimes with these questions, if you just look for the ethanoate part, CH3COO, that's clearly ethanoate. No, no, no. You could have got it first of all, looking for ethanoate. And sometimes looking for the propyl part, 3 carbons connected to an oxygen, 3 carbons connected to an oxygen, 2 carbons, 3 carbons. This is a propyl. This is a propyl. So this is propyl, 1, 2, 3, propanoate. Propyl, propanoate. Anyway, so the answer is propyl ethanoate, and that is A. This is also something you have to remember. The organic product of the reaction between ethanol and ethanoic acid is an ester. You are looking for an ester, and as before, we are looking for that COOC. And here there are two of them. This one's left COOC, COOC. Oh, there's three of them. COOC. There's three esters there. And we are looking for ethanol and ethanoic acid. So there's two carbons on either side of the oxygens. So this one is the only one that fits. That is, that part is ethanol and that part is ethanoic acid. Two carbons on either side of the oxygens. Ethanol, ethanoic acid. So that is the only one that fits. Just to discuss the others, this is a methyl. Methyl, 1, 2, 3, propanoate, methyl propanoate. This is methyl again, 1, 2, methyl ethanoate. And this, of course, is an aldehyde. This is another area of question where you simply have to remember the meaning of various names. A tertiary alcohol. Immediately you hear tertiary alcohol, you've got to scan this and you see immediately this is the tertiary alcohol. We've got COH and you've got three carbons attached to that C. One there and two there. So it's this. That is tertiary alcohol. Just to cover you on what the others are, this is the primary alcohol. Let me write that down. Primary alcohol. This is a secondary alcohol. The characteristics of the primary alcohol are this, CH2OH. The characteristics of the secondary alcohol are CHOH. And the characteristics of the tertiary are COH with 1, 2, 3 carbons. And this, of course, is a ketone. This is a question which you should know the answer immediately. If methane gas is burned in a limited supply of oxygen, then carbon monoxide and carbon dioxide are all possible products. And therefore the answer is D. Something that you should be able to do in 10 seconds or less. This is another question where you're expected to know some basic chemistry, basic organic chemistry. And you must know a little bit about inorganic chemistry in the sense that acidified potassium dichromate solution, if it turns green, it is therefore oxidized something. So, what can it oxidize? You look at the first one, there's no way it can oxidize an acid. It just won't do that. It will oxidize this. This is an aldehyde. It can oxidize that to an acid. It can't oxidize this because this is a ketone, and it can't oxidize this because it's an ester. So the only thing it will oxidize in this list is the aldehyde. When you look at this, you think, I have to do a calculation. I have to calculate the empirical formula, and then given the molar mass, I can work out what the molecular formula. Okay, let's do that. CHO, this is the standard way of doing it, 12 grams of carbon, 2 grams of hydrogen, 16 grams of oxygen. And we divide these by the atomic mass, 12 divided by 12, 2 divided by 1, 16 divided by 16, and that comes to a simple ratio of 1 to 1, which is CH2O. And then you say to yourself, okay, this is the empirical formula, and let's work out what its empirical mass is. So there's 12, 14, and 16, it comes to 30. And we can say, 30 goes into 60 twice. And therefore, the molecular formula is C2H4O2. There you go. And that's that. Now, this is the way to do it if it's paper 2. And with paper 2, you'd get 3 or maybe 4 marks for doing that. a few marks for showing you know how to do this. This is a perfect setup, and an extra mark for getting the correct final answers, and then a further mark for realizing that the molecular formula is this. Okay, so it's 3 or 4 marks. But this is not paper 2. This is paper 1, and you have allowed the question to lead you astray if this is the way you want to do it. Look at this, 60 grams per mole, and quickly look through these and you will see immediately that none of these first 3 can possibly be 60 grams per mole. Even this one, C2, that's 24 plus 4, 28, plus 16, that's 44 grams. None of these can be 60. Therefore, this is the only one, based, even if you just stop there and read, on analysis, compound with a molar mass of 60 grams per mole. What is the molecular formula of the compound? That is sufficient. All the rest was leading you astray. You allowed the question to lead you astray. In paper 2, this would be perfect, wonderful. As I said, 3 or 4 points. In paper 1, why put that extra 20 or 30 seconds into it when in less than 10 seconds you can see 60 grams per mole. Ah, this is 60 grams per mole. Less than 10 seconds. This is another one, just like the previous one, where the examiner is asking you to do, he's not asking you to do a calculation. He's not asking you to do a calculation. He's giving you the data, and you might be encouraged to do a calculation, because if this were paper 2, yes, you would have to do the calculation. But this is not paper 2. Read carefully through these, and lo and behold, you will see this statement here. The molecular formula of the compound is C2H4. No, the molecular formula of the compound is not C2H4. You don't have enough information. You don't have the molar mass. So therefore, this is clearly wrong. 2 is wrong. 2 is wrong. A must be wrong. 2 is wrong. C must be wrong. 2 is wrong. D must be wrong. The only one that is right is B. Now, you haven't looked at 1 and you haven't looked at 3, but it doesn't matter. 2 was the one to eliminate. The molecular formula compound, that's wrong. Now, you can go back to these and think about them. The empirical formula of the compound is CH2. If you do this calculation, you will find that the empirical formula of the compound is CH2. And then you go here. There is not enough information to confirm that the molecular formula of the compound is C2H4. That is true. So 1 is true, 3 is true, 2 is not true. So there are 2 ways of doing this. There's the way the examiner is encouraging you to go, do a calculation. And there's the other way, through the back door, maybe you should say, where you look through it and you see, ah, that's wrong. So all of those containing 2 are wrong. And that's the only one that remains as the right one. B. This is one of those questions where you need to know what an alkane is. And I hope you've studied sufficient alkanes so that you could recognize them immediately. And therefore recognize the ones that are not alkanes. And when you look at this list, you should see immediately that this one is not an alkane. Where you have C3H6, that is clearly not an alkane, that is an alkene. And again, the alkenes are the other group where you should be able to see them immediately, either because the ratio of carbon to hydrogen is 2 to 1, or because you see the CH in the molecular structure. Now in this case, this is not an alkane, and that is the answer for that one. And it can be done in, 5 seconds, 10 seconds to notice that. And it saves you all that time so that you can do on the more difficult questions later on in the paper. This is another question where you need to know the meaning of isomer, and you need to know how many possible isomers there could be with C3H7Cl. As soon as you see C3H7Cl, you know that this is saturated. This C3 is saturated because it derives directly from the alkane, C3H8, which is a saturated molecule. And all it's done, all that has happened, is that one of the hydrogens has been replaced by a chlorine. So that is saturated. And that means the only possibilities for the chlorine are on either the end carbon atom, the Cl there, or it's on a middle carbon atom there. There is no other possibility. And therefore, how many isomers are there? There are only 2. Thank you for watching. If you found this YouTube video helpful, please see my other YouTube videos. Thank you.